Also, if I'm going to tell you everything you need to know about data, I hope they're bringing lunch in. Yeah. Here we go. All right. So I actually changed my talk 2 minutes ago. Yeah, actually, while we were sitting here, what I'm going to talk about is in the world of data and data modeling. There's been a lot of new innovations, which is the topic here, and with good intention, they went this direction, but that veered off this way and created a bunch of other sets of problems in data modeling, which I'll talk about. And then because this morning I was talking to people about BIM, they're saying, well, I'm going to talk about this. I said, yeah, but what about? So I quickly threw in another slide where I'll talk about that. We've got data in different stores without moving it. How do we access it as opposed to moving it? So I'm going to talk about, so the topic is going to be, yeah, that one worked. I think these were covered, the big data topic. So basically, you've got lots of volume, lots of variety, and I won't have to go through all of the details, so I can concentrate more on the topic that I'm going to get into, where it's a wide variety of rates, large amount of data coming in, but on many different types. When you have data of different types, basically, it's a different data structure. People build their application out this direction. The same thing on volumes, and this is now the real-time data world, as discussed already, coming from your cell phone, but in general, basically from electrical grid monitoring, variety of others, and where you need response in subseconds and microseconds. And the new one that's coming up that I'm really hoping people are dealing with real-time data is self-driving cars. If I'm walking across the street and a self-driving car is coming up, I hope he's got real-time data, and I hope he figures out that's me standing in front of him and responds accordingly. So I'll assume, many of you have heard, the wide variety of stories. So let's talk about, from the data point of view, what's been going on in the last 5 to 8 years, and what does this mean? It's different data models. Data model means you got your relational data model, tables and rows, and basically then what they call NoSQL or not only SQL, which is a key value store, meaning here's the index, here's what I want to talk to. Some of us at my age remember index sequential access methods. This is one of those. Also a hash access method. Give me some of that Hadoop stuff. I know that's cool, so I got to have that Hadoop stuff. I got to have some of that sharding. And then you've got your graph databases. This is what Facebook, LinkedIn are built on, is what's called property graphs. There's so a semantic graph based on RDF, or Resource Description Framework. This is if you remember Tim Berners-Lee, who gave us the World Wide Web, is pushing the semantic web, and that's the technology it's based on. It's a different set of data structures. Real-time saying, I got to have an in-memory database. If it's not processed in memory, it won't be fast enough. Traders on Wall Street that are dealing with the matter of it's sub-millisecond. They're down in counting nanoseconds between what can I get. The first one to issue the trade based on the new information is the one that makes the most money. And then finally, for all of us here, the richer data types, your spatial, your imaging, video, audio, etc. All of these have come up with different models, different applications, and guess what? Underneath that, you end up with a different store. That's got to be managed. What's your security model? What's your disaster recovery story? This is just, it's been great for all of the consultants that built this. They got a lot of labor, time there. And now you discover you've got to maintain this, and these all don't talk to each other. So the new capability in the database world is called a multi-model database. And basically, I just shipped our last piece of it, the property graph, shipped in May. So of all of those things that you saw, you can get all of that from Oracle today. Now, obviously, there's Microsoft and IBM, so I'm trying to be fair. We can handle all of these models today, which means under a standard of sitting on top of a standard database substrate, the classic internal Oracle database, you can put in your graph database, your spatial data. We can have a flavor of it that runs just in memory. We'll lock the data in memory if you want maximum performance. People that want a columnar database, because for data warehousing, those compress better. Sure, we can handle columnar databases. All of these types can sit on a standard substrate. That gives you the same security model, basically the same high availability, disaster recovery, and yet your application takes advantage of what is it you're trying to do. If you're really working on a graph problem, you can, because graphs are very flexible. You know, relational databases, people remember, I've got a schema, I got a data definition set. If I want to add something new, I've got to change the schema, and now I've got a database upgrade problem. With graphs, you just add more objects and different relationships. It's very flexible, and it's easier to walk. So all of these are there, but this all then get managed as one single entity, the backup, the restore, the DR, et cetera. So this is all available now, and this is where the industry has forked out into different types. You know, we're saying it's going to start coming back together again because the cost of maintaining all the different models was too expensive. However, because we're a commercial enterprise, look, if you want just one, we'll get you the just one. And now, for example, you've got a small project, you need a NoSQL key value store, that's all I want, don't give me all of the extra stuff. Fine, we have those available. It's just a key value store sitting on top of a file system, it's yours. We have spatial data that just sits on a file system, that's yours. Property graphs, et cetera. That small project is gonna last a few months, you're gonna throw it away. You know, that could be the lowest price and your best choice, and we provide that. But if you're talking about a strategic way to manage data within your company, your department, your section of the government, I would surely, and that's why we built, you know, the multi-model case. Whatever is right for your application, whatever data model that is, we can handle it, but it's all managed as one. This can take you forward for many years. And then, you know, naturally, it's, you know, if you go with the one standard approach, this is what Henry Ford did. It took him about 3 years of hard work to come up with the one standard assembly line. That's your substrate, standard interchangeable parts. You know, it all fits together. You know, and then, you know, we know this changed the whole world of manufacturing and industry. Some people don't know, you know, in case Oracle has spatial and graph, we have points, lines, polygons, you know, basically geocoding, you know, planar topology, network topologies, fully OGC compliant, as well as all of the semantic graphs in Oracle spatial and graph, and now property graphs with it. This is another on the innovation side, is because of the great work at Intel and others, computers now have a lot of cores. You know, that's your vertical scaling, and you can do lots of clusters. And that's basically, if you will, you walk into computer rooms at Oracle, at Google, at Microsoft, you'll see tens of thousands of computers lashed together. So first, vertical scaling. This means, are you going to get your money's worth out of the software? Surely you will from the hardware. You know, and basically Oracle Spatial had, you know, an example. There's a customer that came to us with, I won't tell you the detail of the problem. They said, look, this is really killing us. It takes so long to run this program. So we ran it on a single core machine, 35 hours. We ran it on a 48 core machine. It scaled 47 to 1. And cut it, you know, that much faster. Ran on a 128 core machine, it was 125 times faster. So the parallelism for vertical scaling on your many core machines, as well as scaling out in your clusters, that's the innovation. Look for this. This is throughout all of the Oracle engines, and expect it from wherever you're getting your software. These are another innovation that people said, well, I got to do some knowledge study. I got to have a knowledge database. I've got to do knowledge mining. You know, basically, that's really a graph underneath it. These are words where the property graph, taxonomy, faceted search, et cetera, underneath, it's a graph. We support all of the known graphs, or your spatial, you know, in application terms, is spatial graphs, semantic graphs, property graphs. Every one of these maps into one of those three. So these are all buzzwords that are going on for new innovation, but in reality, they break down into what we have. What this comes down to is, okay, here's your expert that's trying to do the analysis. You know, there's work coming in from the side, whether it's coming from existing databases, you know, material coming in from blogs, mails, financial reports, the latest industry, you know, meshes from, the crop world, et cetera, at some high speed. Then real-time information that's coming in, you know, and electrical network monitoring, et cetera. Your analyst is there trying to work this against your history. And this is where a multi-model database gives you the value there. They can sit there and talk against whatever you've got stored, which no matter which way it was, it was built, you can access it because it's a shared and a very secure store, and also machine processable. That basically this can come in and get machine processed by a machine, generate automatic alerts as necessary. It all depends on which kind of problem you're trying to solve. And I'm going to do two things here because I'm going to lead into what I changed for the BIM people. So because you have so much data and it's complicated, it's often a need to repurpose the data. So this means you've gathered all of this, the spatial data or the other data, you have it in a store. However, different human beings are using this in a different way. It's the same data. So, but basically, as was described earlier, environmental modeling people, agriculture people use their own human language or terminology for talking to this data. The police and the fire may be using some of the same data, but they have their own terminology. You can use an ontology to remap it out into the terminology used by that particular customer, but you only paid to collect the data and store it and model it one time. That's the beauty of providing the semantic layer on top of it. That's when you're sharing the data. Let's see if I did this right. Okay, all right, so the three people that talked to me about BIM, this is the obverse of that. What this is saying, I have several different stores that already exist, and we can't get people to change them. There's too deeply embedded already, and the costs have been spent. So I've got my event, my BI, my content. How do I get that out so different people can use it? You put in then the semantic graph model comes in between, and it knows how to talk to each of the physical stores, but then it remaps the data to the way your person that's trying to analyze the data is looking at it. And that way it's still, you bring out in the terminology you want, even though it's in a different persistent store. Well, how big of a graph can you do? Because these all become graph cases. Very recently, we are asked to do a graph benchmark. This is for the semantics U.S. government agencies, probably some of them nearby, and say, okay, node, link, node, subject, predicate, object. That's a graph. That's the littlest ping. That's called a triple. And you do 1 trillion triples, because they thought, we would fall over it. Said, yeah, of course, let's set it up. There's an industry standard benchmark for measuring graphs. We did 1 trillion triples. It was much faster than they expected even. Not only did we passed going away with flying colors, off-the-shelf software, nothing special here. And we said, look, you want us to do 10 trillion? If you guys will loan us the hardware, we'll crank it up. So we already did 1 trillion. That's the other innovation. Don't worry about scale. You're trying to solve, the human race is trying to solve bigger, harder problems all the time, or they'd be done, as we've discussed earlier. So yes, we can scale, whatever kind of a graph you're getting into. I'll go through these fairly quickly because there's no news here. It's got to be secure. You need a persistent store that's got your encryption, your access control, who tried to attack it. People are hacking cars these days, so you just cannot ignore the security side of it. Last week, for those of some of you who are still here, there was a United Nations meeting up in New York City, and they've, in their work from the 2013, and their new version is going to be coming out shortly, endorsing you need an enhanced data management system. We're happy to bring you one, machine processable descriptions of data, etc. You get there, if you want to really make sure your innovation is going to go quickly and can be shared among other people, you got to go ahead and use standards. ISO TC 11, OGC, W3C in the semantics world, we follow all of these. And clouds are the other piece of innovation. So basically, a private cloud, meaning it's on your premises. Public cloud, this is on someone else's premises. The issue on clouds that comes up somewhat is national policy, national law. So for example, we have 2 cloud sites in Germany because Germany says the data is not leaving our country in many of their cases. Okay, so we've got one in Munich and one in Frankfurt. So the cloud is there, meaning you're sharing the resources, you're sharing the computes, the stores, et cetera. And basically you can set the cloud computer room up wherever the country law is requiring it, or public can be wherever it works out best for the individual. Why want to be doing these and using these, a multimodal database for sharing it, or the semantics? Because hardware cost keeps getting cheaper. We add richer features all the time, because the Moore's law continues, we can add more. The hardware net price goes down, the software net price goes down. The only thing going up basically is the cost of labor and the maintenance of everything you already built. So the people that want you to build custom software and, oh yeah, you got to do it all from scratch with this stuff, that's probably your SI vendor and that's probably your consultants or engineers like me, what I used to be. It was a lot more fun to build it yourself than to use somebody else's. So, and that's the difficulty or the tension that you've got to deal with. But use the off the shelf. You can do this, try to build it yourself. You're gonna, besides the cost of building it, how long is it gonna take? What I talked about, everything I talked about in technology from Oracle, you can get this afternoon. This is not a problem. So how long will this take? What's your opportunity cost? If you're a government agency, what are your citizens asking for, and how soon do they want it? Is there an election coming up where you got to say, look, we're going to have this quickly? We have one in America. I think we got 27 people running at least right now. So how to do it, and then so finally, this is our last innovation. In my last slide, it's a step for you is having a platform that has all of these capabilities today that can handle big and fast data, is integrated with your IT. It can handle your classic IT as well as new wings coming up. A deep amount of analytics software. I didn't go through those, but a lot of analytics with this, and can run in the cloud off the shelf. And ready for you. Thank you.